On October 19, 2017, the Pan-STARRS telescope in Hawaii detected Oumuamua, the first interstellar object with a bizarre shape that defied all known laws of astronomy. While scientists were attempting to study it, it vanished into space at a staggering speed of 315,000 kilometers per hour. This failure prompted NASA to develop the Atlas system, a global network of 4 telescopes capable of scanning the entire night sky every night. In 2025, Atlas proved its worth by detecting the third interstellar object, 3I at last. However, Atlas was completely different from Oumuamua. If we were to let this object disappear like Oumuamua did in 2017, we might miss crucial evidence of extraterrestrial life. What are these objects? Do we have the capability to catch them? Or will we once again miss the opportunity to unravel the universe's greatest mystery? The mystery began on October 19, 2017, when a telescope in Hawaii spotted something racing through the night sky. The Pan-STARRS system, designed to scan for near-Earth asteroids, flagged an unusual streak of light moving too fast for any normal space rock. At first, astronomers thought it might be a comet, but it looked wrong from the start. That strange visitor would later be named ʻOumuamua, a Hawaiian word meaning scout or messenger from afar, and it instantly became one of the most puzzling objects ever seen. This made astronomers question if the basic categories of space objects were enough to explain it. As it moved closer to the sun, the mystery only deepened. When comets heat up, the ice inside them turns to gas and creates a visible tail. But Oumuamua showed no sign of this. Its surface stayed dark and dry, as if it carried no ice at all. Yet when it left the sun behind, something impossible happened. It sped up. Objects in space normally slow down as they climb away from a star's gravity, but Oumuamua gained speed. The push was too strong to be explained by sunlight alone, and without a comet tail, there was no visible force to account for it. This unexplained acceleration shocked the scientific community. Suddenly, Oumuamua was no longer just an asteroid or comet. It became a cultural phenomenon, forcing people to ask whether we had just witnessed evidence of advanced technology from another world. The lack of data only made things worse. By the time astronomers realized Oumuamua was not from our solar system, it was already racing away too fast to catch. No spacecraft was ready to pursue it, and the telescopes we had were too limited to study it in detail. In just a few weeks, the strange visitor faded into the darkness, leaving behind more questions than answers. The frustration in the scientific community was clear. One NASA scientist admitted, "We were caught off guard. We didn't have the tools to study it properly." That failure became a turning point, highlighting just how unprepared humanity was to deal with visitors from the stars. The story of Oumuamua shows how fragile our understanding of the universe really is. For decades, scientists believed they knew the rules of comets and asteroids. They thought they could predict how space objects would behave. Then came this traveler who ignored every expectation, broke every model, and refused to fit into the categories we had created. It was a wake-up call that our solar system is not a closed box, and that objects from other stars can and will pass through. The real question is whether we will be ready the next time. So what lessons did Oumuamua leave behind, and how did it push us to rethink our place in the universe? Oumuamua showed us something shocking. Humanity had no plan for objects from another star. When it appeared in 2017, the scientific community had only days to study it before it slipped away forever. Telescopes scrambled, but by the time they turned to track it, the object was already fading into the dark. That single event revealed a huge gap in our space defenses and our ability to react to cosmic visitors. At the time, most of NASA's attention was on asteroids that could threaten Earth. Billions of dollars had been spent building systems to detect rocks on paths that might collide with our planet. Oumuamua, however, was not one of those. It came in from outside the solar system on a hyperbolic orbit, meaning it was just passing through and never coming back. The equipment we had was not built to handle that. Pan-STARRS caught it almost by accident, and the discovery was only made because of a lucky scan. That realization left many experts uneasy, because it suggested we were depending more on chance than preparation. The real cost of being unprepared was not measured in money, but in lost knowledge. Oumuamua could have answered questions about how other star systems work, what kind of materials they hold, and whether advanced civilizations might exist. Instead, it left without giving us a single close-up image. The frustration was clear when scientists admitted that if we had only known a few months earlier, a mission could have been launched to chase it. Spacecraft like New Horizons, which had flown past Pluto in 2015, could have been redirected to intercept it. But the chance was gone, and all humanity could do was watch it fade. This failure created a wave of urgency in the scientific community. Even private organizations stepped in. The Breakthrough Initiative, funded by billionaire Yuri Milner, announced studies on how to catch the next messenger from the stars. For the first time, humanity realized that space exploration had to become faster, more flexible, and more ambitious. The cost of building such systems is enormous, but the lesson from 2017 made many believe it is worth it. The US spends around $150 million each year tracking asteroids, but interstellar objects may require 10 times that to prepare missions capable of intercepting them. Still, the argument is simple. The next one could contain answers about the origins of life, or even proof of technology not from Earth. If we let another chance slip by, the scientific loss could be greater than any budget. Oumuamua also changed how scientists thought about interstellar traffic. Before 2017, no one had ever seen such an object. Now, estimates suggest that thousands pass through our solar system every year, most too small or too faint to notice. That means Oumuamua was not a one-time visitor, but the first confirmed example of a much larger population. In fact, in 2019, another interstellar traveler named 2I/Borisov was detected, this time looking more like a normal comet. The discovery proved that our solar system is a crossroads for cosmic wanderers, and each one could bring clues we cannot afford to miss. The missed opportunity of Oumuamua taught us a painful truth. Being surprised is not an excuse. In space, every second counts, and once a chance is gone, it may never return. Humanity now faces a choice between building the tools to act quickly or risking the same mistake again. The memory of 2017 still lingers as a warning, reminding us that the universe will not wait for us to be ready. But even as these lessons pushed us forward, another question began to grow louder. If Oumuamua was so unusual, then what exactly was it, and why did it behave in ways no natural object should? The strange shape and motion of Oumuamua opened the door to some of the most controversial theories in modern astronomy. At first, researchers tried to explain it as a natural object, but as data came in, the usual answers began to fail. It was not behaving like any asteroid or comet we had seen before, and every attempt to put it into a familiar category only created more questions. One of the first theories was that Oumuamua was a comet, because comets often change speed when the sun heats their ice, creating jets of gas. That would explain why it was accelerating as it left the solar system. However, telescopes could not find a tail or cloud of dust around it. Comets usually shine with a clear coma of water vapor and particles. Yet Oumuamua stayed strangely clean. This forced scientists to consider the possibility that its surface was coated with a material that kept the gas invisible, or that it was made of substances we had never studied before. Neither explanation was satisfying, but it showed that nature might be hiding tricks we did not expect. Another popular theory claimed that Oumuamua was a fragment of a larger object destroyed in its original star system. It could have been part of a planet torn apart by gravity or a rock shattered by a cosmic collision. Its elongated shape, estimated to be at least 10 times longer than it was wide, supported the idea of a shard instead of a round body. Yet even here, the numbers did not match normal patterns. Most fragments in space become irregular, but not stretched to such extremes. This raised the possibility that whatever process shaped Oumuamua was rare and violent, something we have never witnessed directly. The most dramatic idea came from Avi Loeb, a professor at Harvard. He suggested that Oumuamua might not be natural at all, but rather a piece of alien technology. His team pointed to the fact that the object seemed to accelerate without any visible source of thrust, almost as if it were being pushed by radiation pressure, the force of sunlight itself. For that to happen, the object would have to be extremely thin, like a sheet or a sail. Loeb compared it to a light sail, a device humans have already experimented with, which uses the push of starlight to travel across space. If that were true, then Oumuamua might be debris from another civilization or even a probe sent intentionally. The alien theory divided the scientific community. Some dismissed it as speculation, arguing that extraordinary claims require extraordinary evidence. They insisted that before calling it technology, we must first rule out every natural explanation. Others, however, defended Loeb's courage in raising the question, reminding us that ignoring possibilities simply because they seem unlikely can be a mistake. After all, humanity itself is now developing spacecraft powered by solar sails, so the concept is no longer science fiction. Public reaction made the debate even louder. News outlets quickly turned the story into headlines about alien ships passing through our solar system, and the idea spread across social media. Millions of people became aware of Oumuamua, not because of its scientific mystery, but because of the possibility of visitors from beyond. For many, it was the first time astronomy felt so close to science fiction, blurring the line between discovery and imagination. Beyond aliens, other creative theories emerged. Some suggested Oumuamua could be made of hydrogen ice, a material so unusual that it would sublimate without leaving visible traces. Others proposed that it was a nitrogen iceberg, chipped off from a planet similar to Pluto in another system. These models tried to fit the data, but each required assumptions about cosmic processes we have never confirmed. The more people studied the object, the more it seemed to resist a simple answer. What made the mystery worse was the lack of further data. By the time serious debate began, Oumuamua was already too far away to observe in detail. Scientists were left with only a short window of measurements, taken during the few weeks it was close enough to Earth. That gap means that many theories can never be proven or disproven with certainty. All we can do is argue about which one makes the most sense. Still, the debate itself has had value. It has forced science to admit that our universe may be stranger than our textbooks suggest. Whether Oumuamua was a comet, a shard, or a sail, it showed us that interstellar objects can defy categories. It also reminded us that we must prepare for surprises, because the next visitor could carry even more unusual clues. The theories about Oumuamua are not just about science, they are also about how humanity sees itself. If it were natural, then we would have learned about violent processes in other systems. If it were artificial, then we are not alone, and someone out there is building technology to cross the stars. Both paths are exciting, and both force us to expand our imagination. As the debate continues, one question rises above all others. If another object like Oumuamua appears, will we be ready to find the truth before it disappears into the dark again? The mystery of Oumuamua did not remain inside the walls of observatories. It quickly spread to governments, universities, and space agencies around the world. Once the news broke that a strange visitor from another star had passed through our solar system, the question was no longer only scientific, but also political. Nations wanted to know what it meant, and more importantly, what could be done if another object appeared. NASA was the first to respond with plans for better detection systems. The agency admitted that Oumuamua had caught the world off guard. It had been discovered only because the Pan-STARRS telescope in Hawaii happened to be looking in the right direction at the right time. By the time astronomers realized its speed and path, it was already moving away too fast for a spacecraft to reach. This near miss convinced leaders that humanity needed faster warning systems. The Rubin Observatory in Chile, which will be able to map the sky every few nights with incredible detail. Other countries joined the effort. The European Space Agency started designing projects to intercept interstellar objects, including proposals for probes that could launch quickly and chase a visitor before it disappears. In Japan, JAXA studied how to repurpose asteroid missions into interstellar chasers, while China announced plans for its own rapid response spacecraft. What had once been a quiet branch of astronomy suddenly became a race between nations, not just to watch the skies, but to be the first to capture direct data from an object like Oumuamua. The scientific community also learned important lessons from the failure to gather more information in time. Astronomers understood that without a plan for rapid response, every interstellar visitor would leave only questions and no answers. Workshops were held, and hundreds of papers called for international cooperation. One idea suggested creating a cosmic emergency network, where observatories across the world could instantly share data and shift resources to track new objects the moment they were detected. Another idea was a standing spacecraft, always fueled and ready, that could launch within weeks instead of years. While expensive, supporters argued that the cost was small compared to the value of discovering whether we are alone in the universe. The debate even reached the level of public policy. Lawmakers asked whether the possibility of alien technology should be taken seriously, and if so, what the risks could be. Could such an object be dangerous, either as a natural collision hazard or as something more intentional? While most experts calmed fears by saying that Oumuamua showed no sign of threat, the idea of preparing for the unknown began to influence funding decisions. The event made space exploration feel urgent, not just inspiring. Public interest also reshaped the conversation. Social media turned Oumuamua into a symbol of mystery, and the alien theory drew millions of readers into astronomy who had never cared before. Universities reported spikes in students applying for astrophysics programs, inspired by the idea of chasing interstellar visitors. In that sense, Oumuamua did what no outreach campaign could. It made the cosmos feel alive and unpredictable. For many young people, the idea that a message or a probe could be passing through our solar system was enough to spark a lifelong curiosity. The global response also highlighted the limits of current technology. Even with today's fastest rockets, humanity had no chance to catch up to Oumuamua once it was discovered. The object moved at nearly 315,000 kilometers per hour, far beyond the reach of our spacecraft. To meet the next one, engineers began studying new propulsion systems, including nuclear-powered rockets, advanced ion drives, and even solar sails of our own. The hope is that by the time another visitor appears, we will have the speed and readiness to follow it out into deep space. International cooperation is likely to be the key. Scientists argue that no single country can handle this challenge alone, since interstellar objects can be detected from anywhere on Earth. If the next visitor appears over the southern hemisphere, Chile or South Africa may see it first. If it shows up in the north, it could be spotted by telescopes in Hawaii, Spain, or China. This makes a coordinated response not just useful but necessary. Without sharing data and resources, the world risks missing the chance to learn from these rare encounters. The plans being developed today are shaped by one clear lesson. Time is everything. Oumuamua taught us that once an interstellar visitor is gone, it is gone forever. The only way forward is to prepare in advance, with systems in place to react in hours, not months. That preparation may be costly, but for scientists, the possibility of discovering alien life or unlocking the secrets of distant star systems makes it worth every effort. The story of Oumuamua is not just about one mysterious object, but about how humanity chooses to face the unknown. Will we allow these visitors to pass by, leaving us only with speculation? Or will we build the tools to chase them into the dark? The arrival of Oumuamua was more than a scientific puzzle. It became a mirror reflecting humanity's deepest questions about life, meaning, and our place in the universe. People across cultures and belief systems responded in ways that showed how strongly space mysteries affect not just science, but also philosophy and religion. For centuries, humans have wondered if we are alone, and each time science moves closer to the stars, that question rises again. Some religious leaders said the discovery showed the greatness of creation, proof that the universe is far larger and more mysterious than we once believed. Others feared it might challenge traditional views, since the possibility of alien intelligence could force people to rethink spiritual truths. In either case, the object sparked conversations that reached far beyond astronomy labs. Artists and writers also found inspiration in the mystery. Novels, songs, and even paintings use the image of a silent traveler from another star as a symbol of hope or fear. Some saw it as a messenger, a sign that humanity is not forgotten in the vast dark. Others described it as a warning, a reminder that we are small and unprepared in a universe full of unknowns. Social media spread these interpretations quickly, and for a time, the name Oumuamua appeared everywhere, from science podcasts to late-night comedy shows. The cultural presence of the object proved that mysteries in space are not only scientific events, but also emotional ones. This was important because space had often been treated as a distant frontier, fascinating but unreachable. Oumuamua changed that feeling by making the cosmos seem close, even intrusive, as if another world had reached into ours. The philosophical impact was just as strong. Scholars in ethics and politics began asking questions about how humanity should respond if we ever confirm alien technology. Should it be handled as a scientific discovery, a political secret, or a gift to all humankind? These questions are not just theoretical, because history shows how discoveries can divide societies when power and control are at stake. Some experts warn that if a clear signal or artifact were ever found, nations might compete to control it, just as they compete for oil or rare minerals today. Others argued that such a moment must belong to everyone, because it would represent a turning point for the entire species. Even ordinary people felt these questions on a personal level. In online forums, many discussed whether contact with alien life would erase old divisions between humans, or whether it would only create new ones. Would people finally unite as a single species under one sky? Or would fear and mistrust grow stronger? The lack of answers made the debates even more intense, and in this way, Oumuamua acted like a spark dropped onto dry ground, igniting discussions across science, culture, and belief. There was also a psychological effect that cannot be ignored. Some scientists noticed that the discovery of Oumuamua increased both wonder and anxiety in society. If an object can pass through our solar system without warning, what else might be out there? Unseen and unstoppable. That balance of awe and fear gave the story its lasting power. In classrooms, teachers used the story of Oumuamua to teach not just astronomy, but critical thinking. Students were asked to analyze evidence, compare theories, and decide whether they believed it was natural or artificial. This practice showed how science and philosophy can meet, because sometimes the most important lessons come not from answers, but from learning how to ask the right questions. In this way, Oumuamua influenced education as much as culture, shaping how the next generation will think about mystery and discovery. In the end, the cultural and philosophical impact of Oumuamua may last longer than the scientific data. While telescopes recorded its fading light, people around the world carried the story into their homes, their faiths, and their dreams. It reminded us that the universe is not silent and that questions we thought belonged only to science fiction may soon belong to real life. Oumuamua, the first interstellar object detected passing through our solar system in 2017, defied all known astronomical classifications. Its unusual shape, unexpected acceleration, and sudden disappearance left scientists baffled. This failure exposed humanity's lack of preparedness, prompting advancements like NASA's Atlas system to track future interstellar visitors. The mystery of Oumuamua sparked debates. Was it a natural oddity or potential evidence of extraterrestrial technology? Regardless, it reshaped our understanding of the cosmos, proving that the universe is far stranger than we imagined. Oumuamua taught us that humility and adaptability are essential in the face of the unknown. Our inability to study it thoroughly was not an ending, but a catalyst, inspiring better technology, global collaboration, and bold curiosity. Each new interstellar object is an opportunity to answer humanity's oldest question: are we alone? Let Oumuamua remind us that the universe is full of wonders waiting to be discovered, but only those who dare to prepare, question, and dream will uncover its greatest secrets.